Hello, and welcome to another episode of Sensor Experts. We have a delightful topic I think you'll find just illuminating, and that topic is LiDAR. This stands for Light Detection and Ranging. Now, if you're familiar with LiDAR technology, you know it uses light waves to measure distance, detect objects, and more. You could call it the echolocation of industrial technology. In the same way dolphins use echolocation in nature, things like cars and robotic vacuums use a similar method to navigate their surroundings. While we won't be diving into ocean waters today, we will be diving into the principles of light detection and ranging. LiDAR technology uses light waves as a means of measurement. So just like you would use a ruler to measure the distance between two objects, you could do the same with LiDAR, but it operates on the time of flight principle. This means a LiDAR sensor can send a pulse of light, bounce it off a target, and measure the amount of time it takes to come back. In technical terms, we use the formula R equals C delta T over 2, where R is the distance to the target, C is the speed of light, and delta T is the time it takes for that light pulse to travel from the LiDAR system to the target and back. This basic principle of LiDAR is used in many ways in the industrial automation industry. So let's jump into the different types of LiDAR and where you might see them in the real world. Just like watching a movie in a traditional format versus a three-dimensional version, LiDAR works in these different dimensions as well. 2D, or what you might think of as flat, is typically a single laser that scans the environment in a 2D plane. 2D LiDAR is great in mobile platform applications for navigation, obstacle detection, and mapping. If you think back to that time of flight illustration, the light beams hit objects nearby, so the sensor knows where the platform should and shouldn't go to avoid hitting obstacles. With 3D, the LiDAR now works with a vertical component. Additional planes provide more detection than a single plane would, making 3D LiDAR a better choice for more complex applications, like detecting pallet overhang in a packaging environment. As you've seen, LiDAR technology is used in a lot of scenarios, and some of these scenarios include outdoor environments and other tough ambient conditions, like dust, rain, fog, harsh lighting, and more. It's important for LiDAR products to be able to withstand these kinds of conditions. But how do you make sure your technology is ready to take on those environments? You put them to the test. And to do that, I have our global correspondent at our Outdoor Technology Center. Hey, Evgenii, can you hear me?
Yes, it's raining cats and dogs over here. But that's why we have the Outdoor Technology Center. We can test our tech in the most adverse conditions: extreme sunlight, freezing cold temperatures, dirt, dust, and rain. We put our sensors through it all to make sure they're ready to operate in tricky environments. We can record and analyze sensor parameters in all weather conditions around the clock.
Well, they look like they're holding up pretty well. You, on the other hand.
I don't think I would pass a water ingress test like these sensors would. I've got to get back inside, but if you want to learn more about our Outdoor Technology Center or see more of our sensors put to the test, click the links in the description box for more resources.
And that's our episode on LiDAR. If you have any questions at all, please reach out to info@sick.com. And until next time, keep it smart.